Good afternoon, everyone. Thank you for joining us today for Producing Perfect Models, expert advice on quality models for investment casting. My name is Diane, and I'm part of the marketing team here at Solidscape. Just a few housekeeping items before we begin. All participants are in listen-only mode, so your microphone is muted, but we do encourage your questions. So please submit any questions you might have in the lower right-hand corner of the toolbox, and we'll do our best to answer them during our Q&A session at the end. So we're going to get started today. We have a lot of great information to get to. We're going to start with John Schindler, who's the founder of Schindler Technologies. He's going to take us through Rhino from the design from CAD to 3D printing. Then we have Pedro Loureiro. He is going to take us on a tour of a new exciting product, Panther 3D. And then from our amazing tech team here, we have Matt Tuohy and Erroll Solomon. They're going to talk to us about dewaxing tips and tricks and preparing resin models for printing. So with that, I'd like to hand it over to John Schindler, who is going to talk to us about CAD to 3D printing. So John, take it away.
Okay, can you see my screen?
Yes, all good, John.
Yes, we can see your screen, John.
And that's a screen with Rhino, yes? Because I have to move.
Yes, yep.
Okay, so hello everybody. I'm going to demonstrate how to prepare and send your models to a 3D printer. And for this presentation, I will use the Rhino user interface, but the same concepts apply to any software you want to use. Now, first a little bit of introduction. Only objects which has physical thickness can be 3D printed. To demonstrate this concept, I'm going to create an ellipse. For example, let's say 40 millimeters by 50 millimeters, something like that. So this ellipse is just a curve. I'm going to turn off the gumball. So this ellipse is just a curve. You cannot print it because the curve can only have shape and the length. It does not have any thickness. I'm going to use this curve to create a surface from it. So I'm going to go to Surface Tools, create Surface from Planar Curves, select this ellipse, press Enter. Now we've got a surface. So it looks like it could be printed, but actually cannot. The surface has an area, but it has no thickness. Its thickness is 0. So again, you cannot print it. We need to have anything which has thickness. So I can take this surface, turn on the gumball, and let's say extrude it, say 2 millimeters up. Once I extruded this surface, it becomes a solid, and the solid object is what we can print. Now, what the solid is? The solid is basically usually composed from either single or multiple surfaces joined together. To illustrate that, if I select, I'm going to turn off the gumball now so that it doesn't get in the way. So if I turn on this object and show object properties, you can see that type Rhino shows it's a closed solid polysurface. Closed solid polysurface is the same as the solid object. We can send it to a printer. If I, for example, separated the top surface from it, I can do it by using extract surface. Extract surface, top surface. See, they look the same, but we do not have a solid object. We have two surfaces joined together, and it's an open polysurface, and we have another open surface. And a lot of users make a mistake of trying to group them, and they think that this is a solid. So I could group them. I can use group and select these two objects. And when you click on them, they look like a solid, but they are not. You can see it in the description is grouped variable objects. So I'm going to ungroup. I'm going to undo it, and I just need to join this surface with the rest. To join, use the tool next to explode, which is join. I'm going to select my two joint surfaces and join with this one. And if you look at the command line, Rhino reports 2 surfaces or polysurfaces joined into one closed polysurface. So this is something we can send to the printer. Now, another issue is what format we send the file to the printer. We cannot send the Rhino file. I'm going to turn off this for now and get back to, say, let's delete this guy here and show a ring which I created quickly with Panther. So here we've got the ring. I can show the rendered view of it if you want to see the metals. So this ring is composed, it has 2 parts to it. It has the ring and it has the inlay, which is something like an under the gallery insert. We have 2 options here. If you choose, for example, to print this ring and then for the purpose of cleaning, print the inlay separately and then weld them afterwards, you can do that, but you should not send them like this. You have to take this piece, I'm going to use gumball for that, move it away, and now send both objects. Just to verify if each object is a solid, I'm going to click on this, click Object Properties. It's a closed solid polysurface, so this is a good object to send to the printer. And this is also closed solid polysurfaces. Now let's say I want to print them in one piece. It's a one ring, so I'm going to undo that. Shift, keep them together. You cannot send them like this. You need to combine them into one solid, because presently you have 2 solids. If they are touching, the printer will get confused. You need to, if you want to print one piece, it has to be sent to the printer as one piece. So what we need to do is to combine them. And again, grouping is not going to do anything. We need to use operation called Boolean union. Boolean union will allow us to combine these 2 objects so that they become a single entity. 1, 2, press enter. Sometimes if they are just barely touching, you may have a problem with Boolean, but it worked fine. So now you've got a single object. You can see this is a closed solid polysurface. Once we have the closed solid of the correct quality, we need to convert it to so-called mesh. Now, this model is a mathematically defined model, which has mathematically defined shapes. It's very smooth, and it represents exactly the shape that we want to print. However, the 3D printers will not accept the mathematical description of the model. They need a much simpler definition of this model, which consists mostly of just points on this surface. So what we need to do, we need to convert this model into mesh, which can be then sent as so-called STL file, which stands for stereolithography. To do this, we need to select the ring, click Mesh from Surface Polysurface, and first I want to show you what it means, the density of the mesh, because the mesh consists of a large number of flat faces. All of them have to be flat, which means that they have to be small enough so that we will not see the facets on the printed models. I'm going to show the coarse resolution of it. So let's say I want to use something like 0.5, maximum distance edge to surface, and density 0. Let's see how this looks. Preview. Yes, so this mesh is fairly coarse. Let me do it actually. Yes, I'm going to move the mesh object to the side. mesh here. Just a moment. Mesh. This is the mesh. I'm going to move it to the side so that we have one next to another. So this is the mesh object. And if I turn on flat display, because Rhino is trying to smoothen everything, you can see that we can see some facets on it. This is how this object will print. So we want to make sure that the facets are small enough so that we do not see the facets, but at the same time, they are not too small. If they are very, very small, it may cause problems in processing that file. So I'm going to delete this mesh. I'm going to just undo. Go back to my original ring. Let's turn off Gumball. We don't need it for now. And I want to convert it again. Use this tool, mesh from surface, polysurface. Select the mesh, enter. And the settings that I usually like to use is density is 0.8. Aspect ratio. Aspect ratio defines the length to the width of each mesh element. I usually apply to limit to the length, maximum length of the elements. I don't want to have them longer than 1 millimeter. And the maximum distance edge to surface. This is very important parameter. This parameter defines that when we put the flat face on a curved surface, what would be the maximum distance between both of them? So I want to use something for Solidscape wax printer. I usually use 0.005, or you can even use 0.003. It's also good. And if you have flat faces, you can also clip simple planes, because if there's a flat face, we don't need to have small elements. It could be just simplified one element. Click preview. See the mesh is finer, and click OK to keep mesh. Now we have two objects. We've got the mesh object. We have two meshes actually. One is coarse. Somehow I didn't get delete, so let's go get rid of it. This is our mesh, new mesh. I'm going to hide the poly surface so that it doesn't get in the way. So this is our mesh. And you can see, I'm going to show how dense it is. So this is the density of the mesh. We can also measure, if we want to, the elements of this mesh. So let's say I'm going to use measurement here. Go to analyze. Before I do that, I'm going to use vertex snap, analyze, measure distance, for example, here and here. 0.2 of a millimeter. This is fine. This is actually a good size of mesh, about 0.2, 0.3 of a millimeter. So once we have this mesh, now I'm going to show the range so that to increase a little bit of confusion. So now we have two models. Now, another common mistake is the users sometimes try to use the window selection to send object out the STL file. If you do that, you're going to pick up everything which is there. Presently, you can see that I just picked up one poly surface and one mesh. I want to send just the mesh. So if you want to export the mesh, select with a click and select what you want to export. And here you click Export Selected Objects. Right click, Export Selected Objects. I want to send it to this folder which we have Solidscape Live. Here. I want to call it, say, Signet Hollow, something like that. And when you export, you need to make sure that you're exporting as STL, stereolithography, not as Rhino file. Click Save, and and it's saved as STL file. So this is step one. Now step two, once we have this STL file created, we want to now prepare this model for printing. I'm going to open ModelWorks, which is the software. I'm going to get rid of these models here. Software that comes with, minimize that, with the printer, wax printer. And in this software, you can see the build plate. This is the build plate of the printer. And we need to open this file and position it. And this is up to the user how to position it. So I'm going to click Open. Go to, not this one, let's go to Solidscape Live. And we've got signal. So this is a file that I just saved. Now, usually in design software, the rings are going to be placed vertically. So obviously, on the wax printer, we don't want to print it like this because it will take forever. So the printer prints in layers, and the taller the object, the more time it's going to take to print. So we want to place it horizontally. So I want to rotate this ring, click rotate. And I want to rotate, and this is the x-axis, this is the y-axis, and the z-axis is pointing up. So I'm going to rotate 90 degrees about the x-axis, and I usually like to have the settings or the head facing to the left. So I also want to rotate 90 degrees about the y-axis in the same step. So we've got proper orientation. We want to orient it. I'm going to use auto arrange. You don't need to change much here. So, and we've got one. Now, let's say we want to print something else alongside this. I can do that. I can click the button Append Model, and click, say, Anchor. That's another model that I saved before. And the anchor is vertical. Again, we don't want to print it vertical. We want to place it horizontally. So I'm going to use exactly the same. Rotate, X, Y, Z, and rotate 90 degrees here, and minus 90. Yeah, enter. And there's a very convenient button, which is auto arrange. And that's going to auto arrange all the models on the build plate and make sure that all of them are sitting directly on the build plate. So once we have this, we click this button, Fill button, to prepare the machine file. Here, we have a few options. We can define the slice thickness. This is the thickness of each layer. Remember that the printer prints in layers. And I'm going to use 0.038 of a millimeter layer thickness. It's fine enough. For this machine, it's S390. You can use 25 microns, 31 microns, 39, 45, and 50 microns. I'm going to use 38 for this example. And here you don't really have to change much. You can just click defaults. And this software will save this file with the name of the first file that we had there. So I'm going to leave it as it is, but there will be two models there. Click OK. And this just shows us that one of the layers will not be exactly the thickness of the layer because it does not divide equally, so that's fine. I'm going to click OK. And on the bottom, if you look at the status line, the ModelWorks is showing the progress and it's computing support, because this software automatically creates support structures only where they are necessary. So we've got 262 layers to print. Yeah. It gives us the time estimate when it's finished. I'm going to click OK and show the analyzer. The analyzer is the piece of software that allows us to see each layer as it will be printed on the printer build plate. So you can see two models. I can magnify it if I want to, or zoom it back. And this is the first layer. So the first layer will be just support. The red material is the support wax. It will be melted away, and Matt is going to talk about that. Second layer is also support, and we need these two layers so that we can easily remove the models from the build plate. This is the build plate. This square is the build plate. So you can put as many models as you want. If you have small models, for example, settings, you can also put them inside here. That's fine to utilize the space. So the second layer, the third layer already starts printing build material, and fourth, and so on. I can click play and play all the layers. And it's a good idea to do this, because if sometimes you have some errors in your files, You don't want to spend 7 hours printing and then figure out that something is not working right. So what we are looking for here is the presence, for example, of hollow spaces. So for example, if I stop here at say layer 110, you can see that this is a solid material on the inside of the ring shank, and this is a solid material inside of this anchor. If suddenly it becomes empty, then you know that something is not right. Then you need to get back to the design and check the file. So I'm going to just run it. And it makes sense to spend a minute and make sure that the file is fine so that we don't have any issues with printing. Everything looks correct here. I can zoom it if I want, so you can see if I stop. So this is a cross section of the top of the ring. You can see this is the build material. Any other color than red is build material, and the red is support. So you can see there's no red anywhere else because the other parts is already printed. So this is the very top of the ring. If you look at this plate, it's right there. That's what we are looking at.
John, it's Diane. I hate to interrupt you, but to stay on time with our webinar today, we have about a minute left.
Okay, I'm finishing actually. This is finished.
Okay, thank you so much.
The last step is to send this file. I'm going to just bring it back. Yeah, to send this file to the printer. I'm going to show the printer control panel. This is the control panel which is on the printer, and you can see you can also control the printer remotely from your computer. So this is what's shown on the printer, and I'm going to send this file. So to print, this is the icon that shows if there is a job loaded on the printer or not. So I'm going to click print, and the job that's transferring, because you can control the printer from your computer. You don't have to walk to the printer. You can see the file was loaded. Now it's the printer is checking if the file is correct. And we are ready. And click Start Job, and the printer will print. There's nothing else necessary to do. So that's all for now, and I'll pass it back to Diane.
Thank you so much, John. That was a lot of great information. We really appreciate that. Next up, we have Pedro Loureiro. Pedro is the co-founder of Panther 3D. He's located in Barcelona, Spain, and he is a former CAD manager for Schindler, and he's also a CAD expert. He's going to take us through Panther 3D today. So Pedro, you can take it over, and thank you so much.
Thank you, Diane. Thank you, John. I hope you can hear me and see my screen. Thank you also all the attendees for joining us today. It's a pleasure to be here. And I'm going to do a brief introduction about Panther before a live demo. So I really just want to mention we are a brand new jewelry software in the market, and we are based in Barcelona. Of course, we have a reseller network all around the world. One of them is John Schindler, who just made the presentation in Canada. And of course, our software is focused on jewelry design. You can see that we have a complete CAD tool set. This is just some of the examples to make your life easier when you are modeling jewelry. And we can see in our software all the different builders with all the different possibilities for creating jewelry, for stone setting. And of course, we also keep the history. You can see here one example of a model. We keep the history of all the different tools we have used in order to be able to change or customize anytime we need to adjust the model. It's also important to mention that apart from the Rhino plugin, we are also a Grasshopper plugin, so the users can really take the best from both worlds. I also want just to show a little bit of some samples of the users' work out there, some of the the models made with Panther. And in here you can see different designs, different possibilities. Of course, there is always no limit for that. And also to mention that we are using cycles rendering, the latest integration with Rhino 6. I would really, for those who don't know the software, I really recommend to download the 30 days trial. You can give it a try in our webpage. There are also available online learning resources. So it's all of you are really welcome to experiment the software. Also want to mention that we are in a 50% discount period. We are brand new software in the market. That's why we started with this promotion. We are in euros. It's our price. Actually, I know that the audience is mainly US based, so I also indicated the US approximately cost of the software. I think it's the most important now is to show the software in action. I really just a brief introduction of what we do, but in here
Pedro, I think we might have lost your
I believe
audio.
you can see now.
Okay.
I'm sorry, can you hear me now?
Yes, now we can hear you.
Okay, sorry about that. All right, so as I was saying, in here you can see the Panther interface. I also want to mention that you can also use from Rhino interface. It's available from both. So today I'm going to design here a solitaire with a couple of details. So I'm going to start with the gem on ring. You will see that we will have all the different options in the side panel here on the right. And from this tool, I'm going to choose the ring size. We have here the US ring size chart, any ring size you want. Then we can define the gem cut, the gem size, even the position. Maybe in here I want a little bit higher. And I'm going to move on from here. So once we have the gem, I'm going now to define a setting. We have here several possibilities. And I'm going to use, in this case, the claw setting. So when we are defining a setting, in this case, we need to define the gem, our reference gem. So in here, I just need to select the gem, also the different possibilities. For instance, in this case, I want the depth exactly to respect my ring size. So I will adjust the depth of the claw. And also I will apply a micro setting here on these prongs. So what I'm going to do is to make sure I will leave the thickness enough for this. So maybe a little bit more in here, thickness and width for the prongs. So I want to make sure I will have enough metal to set these gems. But remember that any moment we can come back and readjust. So as you can see here on the side panel, we also keep the different tools we have used so far. So before applying the gems, I'm going just to finish the main structure of the ring, in this case, just to also apply the shank. You will see that we can always start from library parts, and of course from this we can customize. In here maybe I want to make sure it will be touching the claw. Also I want to adjust here the width both on top and on bottom. And from here also want to mention that we are using the gem on ring. We use it originally for the ring size. So this is important to keep the same ring size when we need in the future, for instance, to adjust the ring size, it will automatically be adjusted. So at this point, this is the main structure of the ring. I'm going now to place some gems, make it a little bit more complex and play a little bit with the options to show all the different possibilities. So as I want to place some gems first here on the claw, what I'm going to do first is to ungroup and I'm going to extract under the tools we have the ISO curve. I'm going to extract the ISO curve in here to apply some gem. So I just need to use the gem on curve, and I will select the curve where I want to apply the gems. I also need a reference object for the gem orientation. And finally, we can adjust in here the gem size as I want a micro setting. Also, I want to make sure the position will be exactly where I want. So I want to make sure in here to be something like this, maybe a little bit also in the top. And finally, I need also to adjust the gem orient on the table. So at this point, we have the gems in here. And what I'm going to do now, before multiplying to the other prongs, I'm going to create the settings. I want to make a micro setting. I'm going to use for this the micro cutters. So I just need to select the gems, and from here, let me maybe change to shaded or ghosted. We can see inside. So what I'm going to adjust in here the length of the cutter, also the distance, the space between cutters. I want to make sure I have enough metal to set the gems, as well as the cutter height. So I don't want to cut too much, just enough. So it looks good, but remember that we can always come back and readjust. So I'm going to leave it like this. And I'm going to do the same now, just the channel cutter. I just select the group of gems, and I will need to readjust my cutter width as well as we have all the different options: profile, width, height. In this case, I'm going to adjust, for instance, the caps, make it maybe a sharp one. And also I want to make sure the depth and all that is good for the gem setting. So I use wireframe to see what's going on inside, but it looks quite good. So I just move on from here. So what I'm going to do now is just before making the boolean, I'm going just to use the mirror to duplicate my cutters. So I'm going to select all of them, and I will say that I want both vertical, horizontal, and diagonal, so it will follow up with all the other prongs. And in here we can do now the Boolean difference. So remember that, of course, you can always use the Rhino Boolean, but the advantage of using our Boolean is that it will keep the history. So the idea is that any moment you can go back for addition, so you can always change it, and it will update the results. So I just select objects to remove, and as you can see now, we have the cutters. We just need to do exactly the same step for the gems. We want to multiply the gems around the claw, and as you can see now, before moving on, I just want to mention that all these steps, the main advantage of using the history is that always we can double click, for instance, on the gem and change the gem cut, the gem size, the ring size. So it's really very, very interesting to keep computing with the history. Remember that it will always recompute all the steps in between. So for instance, if I change the gem cut to any of the different cuts, it will update with all the steps we have done so far. So this is really, really interesting to make these objects. Any moment you can come back to it, adjust the same with the ring size. You can, for instance, let's say I want now a ring size 6. So it will calculate the ring size, and this is the plan. Any ring size, any moment you can come back to the model, readjust. You don't need to be worried to make everything exactly perfect on the first time. You can always come back and adjust. The same with a claw, we could adjust. Maybe to finish this one, I could also apply some gems on the shank. This is one example. We just need to select the gem on ring, select the curve, and of course the orientation object. After this, we just need to orient the gems exactly as you want: gem size, gem position, distance between gems, gem cut. There are a lot of possibilities. As you can see, all these different tabs allow you to readjust whatever you need. I'm going once again, I'm going to define the table of the gem as reference for the orientation. And in here to do a different setting type, let's do now, for instance, a prong setting or a bar setting. I'm just going to start with a channel cutter, and from here I think we are good to go. I can maybe adjust here the cap, but we will repeat the process of the Boolean operation and remove this time from the shank. We are removing the channel. So as you can see, we have the gems ready. I'm going to finish this one with under the gem settings, we have the prongs row. And actually under the prongs row, when we select the group of gems, by default, we have, of course, prongs, but we could also do, for instance, under the options we have here, bar setting or even channel setting. So this is one example of what we can do any moment. As I said before, it's really easy to come back to addition and change whatever is necessary. Let's say that, for instance, doing here a bar setting, I want to adjust the distance between gems. I could come here to gems on curve. I can adjust, for instance, the space between gems. Let's say maybe a little bit more. Or even if you want to change for a different gem cut, for instance here, princess cut. So as you can see, this is the idea, very straightforward. This is just a sample solitaire where I wanted to show a couple of different tools, but the main idea of the software is really provide all the advanced jewelry builders with this maximum of possibilities to allow you to design any model you want, and of course then print it with in this case, as we have seen before with the presentation of John, just send this file, which is always closed solid, to print and to move on with the manufacturing. As you can see, maybe I didn't show yet the rendered display. There are quite different materials. For instance, if we want to apply, let's say, a different gem or whatever we want to see, the way we want to see the model. But the main idea of this demo is just to show you how easy it can be to combine the different to create your own, customize it. So from my side, this is what I have prepared. I'm happy to if you have any questions, anything, I'm happy to assist.
Wonderful. Thank you so much, Pedro. Thanks for that demo. That's really exciting, and we'll wait for questions at the end. And if we are unable, you can type any questions that you might have into the question box in your screen. So we appreciate that demo, and now we're going to move on to our technical team. Today we have Matt Tuohy. He's a senior product support specialist here at Solidscape. He's been with us 14 years, and today he is going to take us through tips and tricks for dewaxing.
All right, good afternoon, everyone. I'm just going to take a quick chance here to go over some tips in regards to the dewaxing. One of the most important things here, after you've spent the time printing models overnight, it's most important not to rush the process during the dewax. If you heat things up too hot, you can have a lot of issues with defects, cracking, sizing issues, and it's also very important to use the proper equipment. One of the things that we talk about is the heater stirrers. It's important to get a good heater stir, one that's reliable, but you also need to have a temperature probe because you need to monitor the temperature of the VSO. And we do not want that VSO to get any hotter than the 55 degrees Celsius. We also like to have an assortment of brushes, small brushes, larger brushes, tweezers. Compressed air is probably one of the more important things because that's used to basically dry the models as well as blow off any dust or debris that might collect from the dewax process, as well as an assortment of strainers and different size bowls and containers. So using the different size, different style containers is very helpful, especially if you're printing a lot of flat models. What'll happen is if you use a curved bottom mesh strainer, then your flat piece will tend to curve or deform to the shape of that particular strainer. One of the other issues that I see a lot of people get frustrated with is the size of the mesh. So if you have a small, a piece that has a lot of small prongs, the prongs will actually get stuck in the mesh of the screen and get broken. So one of the ways that we actually improve that is, I make up these little rigs here where I can actually hang the models in the VSO. So this will prevent the models from getting damaged. You can do this a number of different ways. You can just use a paper clip, or some people use string or wire or whatnot. But the real intent here is to keep those models off of the strainer and off from getting caught up in there and causing any breakage. One of the other things that's very, very helpful in this process is to cover the models. So once I've placed the build plate onto the heat source, I like to put a small cover over the top that kind of creates an oven type situation to keep the heat in. This helps speed the process up. We do not want to leave the build plate with the models on the hot plate for any longer than we have to. One of the other things I would also recommend is to wipe off the excess support material after the parts have been removed. If we leave all that excess melted support on there, it's going to build up on the cutter blade. So I prefer to take a little paper towel and wipe off any of that melted material. That way we have a less of a chance of that material getting, deposited back onto the cutter blade itself. So here, this picture just shows you a little bit about the brushes and whatnot, how we use them. I find the little small, I think they're called watercolor brushes, to brush the parts off. You can also use the small, gentle brushes to get into the small cracks and crevices, your settings, your prongs. And this just removes any little bits and pieces that might have collected in there. Same with the compressed air. It's very, very helpful. I think this is one of the more important things because this will really, really clean the models good. and it'll also get a lot of that VSO off of the model itself. The VSO is not really, you don't really want to have a soaking wet model, especially if you're going right into casting. So the compressed air will also clean it up for you and dry the VSO. Some people like to coat the models with mineral oil to preserve the surface, but most of the time, if you're going direct to casting, this shouldn't be too much of an issue. And I also recommend having multiple hot plates. This way you can have one that's heating up the VSO while you're removing the models from the build plate. And the most important thing here is do not use a kitchen type hot plate. Those are very, very dangerous as they're an uncontrolled heat source. So again, just overall, take the time to dewax properly. Don't rush. Do not use kitchen type hot plates, and keep the VSO temperature at 55°C or below. And just some ways that you can reach out with additional questions moving forward. And Diane, I'll hand it back to you.
Thanks, Matt. That was a lot of great information there. Next up, we have Erroll Solomon. He's a product support specialist here at Solidscape. He's been with us 9 years, has over 30 years in the technical support field, and like Matt, travels the world for Solidscape, helping our customers out. So today, Erroll's going to talk to us about preparing resin models for printers. So Erroll, I'm going to hand it over to you.
All right. Thanks, Diane. Hopefully you can see the screen. I would like to go over some general tips that will help our users create resin models that are both well supported and easy to work with. These are general ideas that should work with most resin 3D printers that are similar to the Solidscape DL. So to begin, create or load your file into your preferred CAD software or printer software. Make sure that that STL file is watertight or Boolean joined, as John mentioned earlier, and has no errors. Some CAD software can automatically detect a defective file and attempt repairs, but it is always best to start with a good file than to waste time and material on a bad file. Once the file is loaded, you can begin to add the support structures, and when all of the support structures have been added, you can load the files onto your printer. So orient the model in order to minimize the number of supports that need to be added and to achieve the best model quality. The less supports that there are, the less post-processing that will need to be done. Always strive for the best model quality. Make sure that the model fits within the build area in all directions. Now, some CAD software will display an error if it recognizes that the model is outside of the build area. Orienting the feature or crown of a ring, as John mentioned earlier, but in this case of a ring vertically because we're doing resin, and then applying a 15-degree rotation in the X and Y axis will often enable a higher quality grow. Parts should be arranged in order to minimize the number of supports by ensuring that prongs and features and edges are located between 9 and 3 o'clock. And as always, support models at the lowest point. Parts with CAD created supports can be imported and arranged without further processing if you have that software. Parts should be arranged to minimize the X and Y cross-section on any given layer. And just remember that different materials, different resins will have different needs. If your software has an auto support function, then try your CAD's auto support function. It may or may not provide enough or proper supports. However, using that auto support function with different orientations of the model can help determine the best way to orient that model. Use the orientation that requires the least amount of supports and provides the best processing. So if you look at the model on the left, you'll see that there's a number of supports, and they're also in a place of the ring that when you post-process that, you might be hard to get rid of the pits, whereas the model on the right-hand side just uses an anchor, which would be easier to post-process later on. Make sure that supports don't touch or pass through a model if it's a complex model. And again, consider that entire manufacturing process when adding anchors or supports so that you can reduce the number of supports where feasible. If you look at the model on the left, you'll notice that it did require 2 supports, but the model on the right just needs an anchor, much easier to post-process. Some software has a feature called a bouquet structure, and if that's available to you, then those long supports can be connected or grouped, and this will increase the strength of the supports. Massive parts with large cross sections per layer will risk delaminating or layer separation, falling off of the build platform, or just failed builds. Massive parts need more supports, even when they're anchored to the plate. Parts that have large cross sections, again, need more supports. Notice the model on the left needs more supports than the simple and lighter model on the right, which just can get away with an anchor. Overhangs are areas in a model that are not supported by a previous layer. So orient models in order to minimize your overhangs. Parts that have large overhangs need to have those overhangs supported. Areas that are overhangs will not be printed unless properly supported. And parts that have small angles from the horizontal are similar to overhangs, and they also need to be supported. You'll notice on the left-hand side, no support is needed because there are no overhangs, but as you move to the right, either you have a large overhang or you'll have angles that still need to be supported. For horizontal surfaces, make sure that the supports are within 1 millimeter of each other to minimize drooping, as shown on the rightmost model. Place supports in places that have easy access for removal and post-processing, taking into consideration that full workflow and the manufacturing process. Place supports in places that do not affect the design of the model, unlike the middle model. Avoid orientations that have surfaces that are parallel to the horizontal plane, unlike the leftmost model. Start with using more supports because it's better to have a few extra supports than to ruin a model. And start with using thicker supports because with experience, you may be able to modify those supports later on. Once again, make sure to preserve, if possible, the detail of the model. So you would try not to have supports where there's a lot of detail, say, around the side of this ring, because that way it will be hard to remove those supports if they're in the detail. Make sure to support the perimeter of the model. Remember, support should be no more than 1 millimeter apart. And make sure to support the lowest part of the model. Any unsupported areas may deform. And you can manually create supports and settings and save them in some software. One set can be defined for detailed parts, another set for massive parts. Different sets can be used for the same part. Sets can be imported from other users in some software. You can create and modify default parts from the software's part library to use for supports and anchors. And just as a last thing here, just a slide of some of the features that are available and some of the different parts of the supports. And it's good to know what these are because when you know what they are, then you can see how they will affect your model. Just remember that different software may have different names for the same parts. So breaking point width, breaking point height, these all affect how the support will be attached to the model. I hope this information has been very helpful to you, and thank you for your time. And with that, I'm going to pass it back to Diane.
Thank you so much, Erroll. That was a lot of great information. We really appreciate it. Unfortunately, we don't have time for questions today, but we will respond to you directly. We will send you, responses to your questions directly. And we thank you for your time. We know your time is valuable, so we really appreciate your participation. If you do have any further questions or want more information, please feel free to contact us. You can visit our website at www.solidscape.com. Thank you to all our panelists today and all of you for attending, and have a wonderful rest of your day. Bye-bye.